This is an 8-bit computer that I have designed. So right here we have the RAM, and I'm going to be using the TC551001 BPL. It's a Toshiba chip. And for the memory address register, I'll be using the 74LS273. And for the input and output buffer, I'll be using a 74ALS245. It's a bidirectional buffer. For the program counters, I'll be using a 74LS193, and I'll be putting them in parallel to create an 8-bit word. And for the accumulator, I'm using the 74LS273 again. And to output the data onto the bus, I'm using the 74HC541. For the B register, I'm also using the 74LS273. And to output its data onto the bus, I'm using the 74LS244. For the output register, I'm using a 74LS273 again. And then I'll be getting into this later. It's just the output parts and back into Arduino so it could process data. And over here, I have a port in register so it could read data from like a keyboard or something. And I'm using the 74LS273. Down here for the instruction register, I'm using 4 7474D flip-flops. And over here, the ALU, I'm using two 74LS181s, and I'm putting them in parallel to create an 8-bit ALU. And the ALU has 6 select lines, so I'm going to use a 6 input D flip-flop, but I'll still be using the 74LS273, but only 6 inputs, 6 outputs. The other 2 will be excluded. And I also have a C register, and what this register does is it outputs its data into a 8-bit comparator. So 8 bits from the C register, 8 bits that get read from this buffer. It's a 74LS241. What it does is it compares the 8 bits, whether it's equal, greater than, less than, and it puts that into a decoder, which I'll be getting into next. So here I'm going to be using an Arduino Mega for the decoder. Mainly because I don't have access to any ROM chips, and yeah, I think it'd be easier just to program the Arduino with all the instructions set and all that. And I'm also using a binary counter, 74LS163, and a 3 to 8 line, sorry. This is just for my architecture. I'm going to be using, actually, I'll be using 3 lines and 8 outputs, but my instructions only use, I think, 6 T stages, I think. So I'll still be using the 74, 130, 138. And over here we have the output for the ALU. So it's a 74LS241. And over here I'm using 74LS373s. One's for the port out, so I could output data, and it could go somewhere else like an external DAC or something. And over here I have a register to go to the Arduino. And I'll be using a separate Arduino, like a mini or something. And that could like drive an LCD. It could drive anything really. And yeah, that's basically my architecture. And here are my instructions. So I have load A, load S, load C, load integer, move A register to B register, move B register to A register, store A in RAM, jump if equal, jump if greater, jump if less than, output to port, output to Arduino, read from port, and then the A register to C, and then halt. If there's any instructions that are more helpful than others, I think it'd be appreciated if you guys could tell me. And here's my old architecture. Like, these are just rough copies. This is the first one I made. It had lots of mistakes, so I just had to redo it. And I think here are the T stages. I still need to make a good copy for this. and this is what I'm going to program into the Arduino. I think there's like 80 conditions or something. Yeah, here's some. I'm just writing some details about each instruction. So I've just wrote details about the load A, like everything about load A. And here's load S, everything about load S. As you can see, XX, that means like it doesn't matter because I'm only using 6 of the inputs to put into the ALU, because the ALU has 4 selects and then two lines, one to select for logic operations, one to select for arithmetic. And yeah,